Now that we've learned a little bit about making CO2 dry ice, I thought I wanted to try another compound. And of course, this is the compound, a remnant of my misspent youth and definitely not a factor in my misspent adulthood. This is nitrous oxide N2O. It's very interesting because it has some significant similarities to carbon dioxide. It also has a molecular weight of 44. Its critical temperature is 34 degrees C. CO2's critical temperature is 31 degrees C. When you put it in a compressed cylinder, it exists in there as a liquid in a gas phase, and the vapor pressure at room temperature of nitrous oxide is about 735 psi. So again, not that different from CO2 in many ways. The difference though is that CO2 freezes at minus 50 C. Nitrous oxide freezes at minus 90 C. So I'm not sure that I can get to minus 90 C using a condensation rig, but I'm certainly willing to try. There are particular reasons why I need to be very careful around nitrous oxide, which I don't intend to elaborate for you today. Not the least of which, of course, is that it interferes with the methylation of your DNA. So you don't want to have this stuff around any more than you absolutely have to. This is a fascinating little device. In essence, it's a pin that will puncture the end of this, and the gas will come out of here. You drop it in here, screw it down to press the thing against the pin, and out comes the gas. I'm just going to put that onto a modified version of my fill apparatus. Now I know that this thing will take 3,000 psi because I blew out a 3,000 psi burst disk with my CO2 experiments, but I'm pretty sure this plastic won't take 3,000 psi. I am going to give it a little bit of reinforcement here because I really can't afford to break this. It's the only one I've got. If I have to, I'll resort to filling balloons, and which would again be harkening back my misspent youth, and then I will just pump those balloons into the tank. I'd rather avoid that if I can, though. So we'll do a little experimenting and then we'll give it a shot. So that should be at least 50, that should be about 50 liters or 80 grams. I don't think it actually is. I think I'm losing a lot. I'm going to go ahead and get this thing up to about 400 psi. Here's my setup. I'm going to go ahead and just start emptying nitrous oxide cartridges into this thing. I'm going to put 50 in at 8 grams a piece. That's 400 grams, which is also about 250 liters of nitrous oxide. And every 50 liters, I'll just put it on the pump and put it into my cylinder here. And then we'll do what we did with the CO2 and see if we can make dry ice. If this thing lets go, you're going to watch me scoot, because I'm frankly afraid of getting anesthetized and acting like a jerk or falling over and getting hurt or something like that. So watch me run. Alrighty, so that's the first 10. Let's pump it into the tank. I'm going to lose a little bit because I'm going to do a quick purr. Run 1 was a nominal 80-gram run, and I actually put, oh my, 33 grams into the cylinder. I got to see if I can improve the efficiency a bit here. I mean, at the end of run number 3, and you can see I'm over 800 psi. We saw that with the CO2, that the stuff gets warmed up so it doesn't conform ideally to the 735 psi that we should see as the stuff starts to liquefy. I weighed these cartridges and they lost 76 grams, so 7.6 grams per cartridge when I emptied them, and this thing added 51 grams. So I'm at about a 2/3 efficiency here. I'm just not sure. I guess got a leak somewhere. Stuff is cold. That's frost on there. I'm going to go ahead and let this thing warm up because the balloon got so cold that it didn't fit the fitting anymore because the PVC shrank. So I'm going to let things settle off temperature-wise here just for a second, and then I'll be back at it. While I'm letting everything else temperature equilibrate, let me show you this. This is the tank after I let it sit in the ice water that I'm using to cool my pump. And so it went from 850 to just under 700 psi just in the time frame that I put it in there, which was no more than 5 minutes. It's around 17 C now. It's dropped from about 23 C. So it is acting just like the CO2 did. So I've done 7 runs of 10 whippets each. So this is like the world's largest whippet right here. That's 70 of these little things. 50 cents a piece, by the way, so $38, no, $35. And if they're actually 7.6 grams a piece, which is about what I measured, that's 532 grams of nitrous oxide. And this thing has 361 grams of nitrous oxide in it. So that's a conversion rate of, I think, 68%. I don't know where the rest of it went. I mean, it seemed like a relatively closed system, but I got a leak somewhere, I guess. Anyway, 68%. So at that rate, this is a one-shot deal. I can't try this again. So I think what I'll do, what I'm going to do is go ahead and get my horn on here, and then we'll pop it in the fridge. It's nighttime, so I'm not going to do this tonight, obviously. I'll take this and put it in the freezer, and we'll blow it tomorrow. See what we get. Hopefully we'll make some dry ice. And if we don't, well, it's an expensive boondoggle, and either way, because it cost me a fair amount of money, I'm putting it on YouTube. Well, there really is no time like the present to go ahead and take this shot. So my CO2 yield is around 16%. I'm going to assume, since I'm going for over 30 degrees C colder, that my yield is going to be lower than that. I don't know how much lower. And you can hear I'm leaking, so I got to go now. Look, the liquid's leaking out of the bag. And there's the solid. I made it. I actually made dry ice from nitrous oxide. I made 13 grams of dry ice from nitrous oxide. Let's see if we can get it to come out so we can look at it, because I don't think it's going to last long. I don't know if I can actually show it to you. It's like embedded in the cloth or something. And it's just going fast, fast, fast. There it is, but it's going to evaporate before I can get it out to show you. It's incredibly cold. There is just a vanishingly small trace of solid nitrous oxide. So it actually can be done. It just can't be done in any sort of elegant fashion. I'm going to taste this stuff. Ooh, yeah, yeah. The reason is it's supposed to be sweet. Of course, I'm trying not to inhale it because I don't want to get goofy. There's a little piece right there. Let's take that. Oh, I feel like Flick in A Christmas Story and getting my tongue on the post. Well, so I did actually from nitrous oxide in a vanishingly small quantity. It's kind of fun to know that it can actually be done. There it is. My poor tongue. Okay, well, you know what? That's pretty much all I got because I can't afford to do that again. Thanks very much for tuning in for that. I think that's another YouTube first. I've never seen anybody deliberately making solid dry ice. There's some more for you, by the way, from nitrous oxide. Sit here and watch it sublimate. Anyway, thanks very much for watching. Please feel free to like and subscribe if you want. You don't have to. I mean, every so often I actually produce some content that no one's ever produced, and again, here's an example of my having done that, so that might be worth hitting the old subscribe button. Tell your friends if you'd like. Of course, if you don't want to tell them, you don't have to. Anyway, thanks very much for watching, and have a great day. So let's go back and look at these phase diagrams for just a second, because something weird happened here. So here's CO2 on the right, nitrous on the left, and here's the temperature for the triple point of CO2 at 216, or about minus 50-ish, 55-ish. And here's the triple point for nitrous oxide, so it's about 35 points lower in temperature. But the thing about it is the pressure. So the pressure of the triple point for CO2 is 5.2-ish atmospheres, whereas for nitrous oxide, it's about 0.88 atmospheres. Now remember, this is the liquid phase, gas phase, solid phase. So if you lower the pressure below 5.8 atmospheres, or maybe somewhat lower, you really can't get liquid CO2. It stops right there at 5.1819 atmospheres. Whereas liquid nitrous oxide can exist at 1 atmosphere because it's above the atmospheric pressure of the triple point. So as long as it's cold enough, you can get liquid nitrous oxide, but you cannot get liquid CO2. And I think you can see it in these comparative pictures of my two release experiments. I mean, you can see liquid nitrous oxide coming through the walls of my bag in this shot. And I think that's the reason why it froze so weirdly, because it actually froze inside the walls of the bag, and there was very little actual frozen nitrous oxide to see. I think actually if I repeat this experiment by using a bag that is maybe a little larger and is not made of cloth like this, I might actually be able to capture liquid nitrous oxide in the wild outside of a compressed environment. Now, it's not going to last very long. And if I don't have all my liquid blowing through the walls of the bag, I might actually get more solid too, which of course means I'm going to have to do this again annoyingly, because I wanted this to be a one and done since it's kind of an expensive experiment. Anyway, thanks for watching.